In this video, you will learn the different intermolecular forces. What is intermolecular forces? It is the force in between the different molecules. Let's say you have a molecule over here, you have a molecule over here, and that is the force in between these two different molecules. It is not the force within a molecule. For example, if you have a bond over here, this one, it is a covalent bond. It is within a molecule. Any forces within a molecule over here that is connecting, it is called intramolecular force. Okay, so all the covalent bonds, they are not intermolecular forces. Okay, so what causes the intermolecular force is caused by the Coulomb's force. That must be charges. Okay, so if you have a molecule over here, and if there is some forces between this molecule with this molecule, there must be some sort of charges. For example, if this one is partial positive, this one is partially negative charge, then they have a force to attract each other. Okay, so what is the simplest one to begin with? Let's look at this way. How come we see gases? Let's have a container over here and there are gas molecules. How come these molecules, they fly around, they travel around instead of forming a liquid like this? And the reason is because they do not have enough intermolecular force that is holding them together and to be a liquid. Okay, so let's get started. The simplest one is called dipole-dipole attraction. Let's use a molecule, hydrogen chloride or hydrochloric acid, as an example, because it has different electron negativities, and therefore the electron will be preferred to go to one side of the molecule and making it partially negative on this side and partially positive on this side. The other molecule will be similar. Let's say if we have Cl over here and an H over here. What would be the preferred case? If they can have random motion, and after a while, this partial charge positive can find the partial charge negative. And therefore, later on, what you can see is, let's say they both can move in randomly. This one, and it will be very easily that this positive can get attracted to the partially negative, and this partially negative can get attracted to the partial positive. In this case, I have the positive that is closer to the negative because they attract each other, So this way they will be happy. And in this case, because this partial charge is induced by the polarity of this covalent bond, okay, and therefore creating a dipole moment, the partially charged positive will be attracted to the partially charged negative, and therefore we call this type of bond the bond between these two molecules, and this is called the dipole-dipole attraction or dipole-dipole force. There are different types of dipole-dipole force. To some extent, if this dipole-dipole force involves with oxygen or nitrogen, for example, oxygen, it will have either one or two pairs of lone pair electrons. This pair of lone pair electrons will be very polar as compared with the other type of bonds. Let's use a water molecule, for example. So there are water molecules, there are two pairs of lone pair electrons, and therefore making the molecules, if we look at it from the sideway, so there will be a partially negative charge over here and a partially charged positive over here with the hydrogen. Okay, so this partially charged negative oxygen will be attracted by the other hydrogen that is partially charged. So let me put a dashed line instead. It will be attracted to it. Oxygen over here with lone pair. This lone pair will create a force over here. So this one is also dipole-dipole attraction because it's made from an atom with lone pair electrons, and it is so strong, so it will have its own category, and it is called hydrogen bond. Hydrogen bonding. Hydrogen bonding, it will involve with hydrogen, and usually it will involve either with oxygen with lone pair electrons or nitrogen with lone pair electrons. So the dipole-dipole attraction that is due to the hydrogen and these atoms with lone pair electrons, we call that hydrogen bonding. Okay, sometimes you may say, is there any other type of intermolecular force? For example, if we dissolved table salt in water, how come these ions, how come they don't evaporate out? Well, because this Na plus, it will be holding back by the negative chlorine. That's the first thing. The second thing is when sodium chloride is dissolved in water, because as we have mentioned before, water will be partially positive charge over here and partially negative charge on the oxygen. And therefore, these positive negative or partially charged negative will be attracted to the nitrogen and will be holding it back without letting it escape or evaporate. This type of intermolecular force, it is called ion dipole. The dipole part is from water, and the ionic part, the ion part is from the ion. Okay, what about with something that has no partially charge? For example, you may have played with this one before. If you have a comb, after you comb your hair, it can pick up the small part of paper. Okay, so what happened? The paper, right after you shred it, it has no static charge. However, only the comb, when you comb your hair, you will generate some charge over here, either positive or negative. Let's say it is positive. So right after you comb your hair, you generate positive charge, static charge on the comb. However, the paper is neutral, it has no charge. So how come you can pick it up? Well, this one, there is an induced force in it. Let's say this is a piece of paper, it is neutral. But when the comb gets close to it, when there are many positive over here get close to it, what happens is it will push all the negative to the other side. Well, the opposite, it will push all the positive to the other side, and it will attract the negative to the close side to the positive charge. So this is called the induced charge. After this, then because the negative is on this side, and now you feel a force over here because the attraction force will be larger than the repelling force because it already pushed the positive to the other side. With the similar principle, it is the same for molecules. For example, if there is a molecule that is very symmetrical, for example, if I have a methane gas, even though the bonds are a little bit polar, but since it balances out in each direction, and therefore this molecule, there is no dipole moment, and therefore it will not have any preferred charge in any direction. In this case, how can this molecule be attracted to another same molecule, because there's no typical force around it? So what happens is it will have the same principle as the comb and paper over here. It will induce a charge. And therefore, with this type of intermolecular force, we call that London's dispersion. Force. Or sometimes it's just called the dispersion force. That means when you have a molecule that is very symmetrical without any net charge in any direction. And how can those molecules become a liquid and get to each other, get attracted to each other? It is by a London's dispersion force, where the charge will suddenly be induced into one direction and therefore leaving the negative charge or the opposite charge in the other direction. This will only happen to the molecules that has no obvious net charge in any direction and it's very symmetrical. So in summary, we have seen 4 different types of intermolecular forces. They are dipole attraction, they are hydrogen bonding, and we have seen ion dipole attraction, as well as the London's dispersion force.